Today, we are on the hunt for one of the greatest secrets in our cosmic neighborhood, hidden oceans, and yeah, the life they just might contain.
It's probably the biggest question we can possibly ask, right? For generations, we've looked up at the stars, searching for planets that look a lot like our own. But what if we've been looking in all the wrong places?
Because the evidence is really starting to pile up that the most promising places for life beyond Earth, well, they aren't these warm, sunlit worlds we've always pictured.
That's right, we're talking about ocean worlds, these icy moons orbiting giant planets where vast liquid seas are churning far, far away from the sun's warmth. This is where the hunt is really focused right now.
So how do we even start to search for life in places that are so alien? Well, it's not just a random shot in the dark. Scientists are actually guided by a simple but really powerful idea, a kind of recipe for life as we know it.
So this recipe has three main ingredients. First, you need liquid water. It's the ultimate solvent. Second, you gotta have the right chemistry, elements like carbon, that are the basic building blocks of life. And third, you need a source of energy to get everything going. If you can find a place that has all three, you've just found a world that could potentially host life.
Okay, now here's the part that really blows the whole thing wide open, that energy source. We always think of the sun, right? But here on our own planet, deep on the ocean floor where sunlight has never, ever reached, we found these incredible ecosystems just teeming with life. Giant tube worms, strange fish, fields of crabs, all of them thriving in total darkness around what are called hydrothermal vents. They're running on chemical energy, not solar energy. This discovery completely changed the game, opening up the very real possibility of life in dark, icy oceans super far from the sun.
So, with our recipe in hand, let's go meet the prime suspects in this search. These are the worlds where we see the strongest evidence for those three key ingredients.
The two heavy hitters are Jupiter's moon Europa and Saturn's moon Enceladus. Now, Europa is massive. It probably has an ocean with more water than all of Earth's oceans combined, but it's locked away under this really thick, tough-to-crack ice shell. Enceladus, on the other hand, is tiny, but it's incredibly generous. It's actively spraying its ocean out into space through these huge geysers, basically handing us a free sample to go and analyze.
And this quote just nails why those plumes are such a game changer. They solve the single biggest problem of exploring these worlds. We don't have to figure out how to drill through miles and miles of ice. This elevator brings the ocean right to us, letting a spacecraft just fly right through it and get a taste of its chemistry.
And it's not just those two. We've got other fascinating suspects. There's Titan, another one of Saturn's moons, which has liquid methane lakes on its surface and incredibly complex organic chemistry. And then there's Ganymede, Jupiter's biggest moon. It's so big it has its own magnetic field, which is a huge clue that there's a salty ocean deep inside. Every single one of these is a unique world with its own set of mysteries.
Now, this isn't just theory or science fiction. We have an entire fleet of robotic detectives that are either already on their way or are getting ready to launch to go investigate these worlds up close. Just look at this timeline. It shows you exactly how this is all going to unfold over the next decade. Europe's JUICE mission and NASA's Europa Clipper, they're already flying towards Jupiter as we speak. And in just a few years, Dragonfly will start its long journey to Titan. This is happening right now. By the early 2030s, we are going to be in a golden age of exploring these ocean worlds.
But exploring these places is unbelievably difficult. Let's take Europa Clipper. You might wonder, why does it do 49 quick flybys instead of just, settling into orbit? The reason is simple, and it's deadly.
Jupiter's magnetic field creates these radiation belts that are about 20,000 times more intense than what we have here around Earth. That kind of environment would just fry a spacecraft's electronics. So the engineers came up with this brilliant solution. The spacecraft will orbit the much safer Jupiter and just make these quick, daring dashes past Europa to collect data before zipping back out to safety.
Meanwhile, the Dragonfly mission to Titan is a totally different kind of explorer. It's not an orbiter at all. It's a car-sized, nuclear-powered drone that's designed to fly through Titan's thick atmosphere. It's going to land, it's going to sample materials, and then it's going to take off and fly to a whole new spot, basically acting like a robotic field geologist on an alien world. It's incredible.
So, with these amazing missions, what are we actually looking for? It's really important to be clear about this. We are not expecting to find little green men. The scientific search is way more methodical, and it all comes down to understanding what finding life actually means.
The key term you're going to hear a lot is biosignature. And a biosignature isn't life itself, it's the evidence of life. A chemical, a mineral, a complex pattern that is really hard to explain without biology being involved. But, and this is the crucial part, every potential biosignature has to be checked against every other possible non-biological explanation. And finding one isn't some single eureka moment. It's a careful, painstaking, step-by-step process. It starts with distant hints, which leads to reconnaissance missions like Clipper to map the whole environment. Then you move to what's called in situ sampling, which just means analyzing material right there on the spot. Only after you've ruled out all the other possibilities can scientists start to build a body of evidence that's strong enough to make a real claim.
All of this brings us to the next decade, which I have to say promises to be one of the most exciting in the entire history of planetary exploration. So what should we be keeping an eye out for?
All right, let's recap the big takeaways. First, the most promising places to look for life might not be like Earth at all, but these dark, hidden oceans under ice. Second, our search is guided by that simple recipe: water, chemistry, and energy. Third, a fleet of amazing robotic explorers is already on its way to test these worlds. And finally, their goal isn't some single gotcha moment, but to painstakingly build the case for a biosignature.
In just a little over a decade, missions like Europa Clipper, JUICE, and Dragonfly are going to give us our first detailed look inside these mysterious worlds. They're designed to tell us if these oceans are truly habitable. And what they find, well, it could change our understanding of life and our place in the universe forever. The hunt is on.